this video, we're going to explore everything you need to know about linear equations. We'll start by understanding what a linear equation is, break down the meaning of slope and y-intercept, learn how to graph them step by step, and see how they're used in real-life situations in physics. By the end of this video, you'll have a strong foundation in linear equations and feel confident solving and graphing them on your own. Let's look at a real-world example to understand linear equations better. Imagine you are buying pens online. Each pen costs $2, and the shipping cost is a flat $3 no matter how many pens you buy. We can write this as an equation. Total cost equals 2 times the number of pens plus 3. In math terms, that's y equals 2x plus 3, where x is the number of pens and y is the total cost. If you buy one pen, the total cost is 2 times 1 plus 3, which is $5. This graph is just one example of how linear equations can represent real problems. A linear equation is an equation that graphs as a straight line. It has two forms. The slope-intercept form and standard form. This is the slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Understanding this equation is the key to solving many algebra problems in the future. Next, let's understand slope with a few examples. Remember, slope is the steepness of a line and is calculated as rise over run. For y equals x, the slope is 1 because it rises 1 unit for every 1 unit it moves right. We calculate this as slope equals 1 over 1, which is 1. For y equals negative x, the slope is negative 1 because it goes down 1 unit for every 1 unit it moves right. We calculate this as slope equals negative 1 over 1, which is equal to negative 1. Finally, for y equals 2, the line is horizontal with a slope of 0 because it does not rise at all. We calculate this as slope equals 0 over infinity, which is just equal to 0. Now, let's understand the y-intercept. Remember, the y-intercept is where the line crosses the y-axis. First, let's look at y equals x plus 1. Here the y-intercept is 1. So the line crosses the y-axis at the point 0, 1. Next, for y equals x minus 2, the y-intercept is negative 2, meaning the line crosses the y-axis at 0, negative 2. Finally, if we look at the line y equals x plus 3, the y-intercept is 3, so it crosses the y-axis at 0, 3. No matter what the slope is, the y-intercept will always show where the line meets the y-axis on the graph. Let's look at the line with a y-intercept of 1 and a slope of 2. The y-intercept of 1 means the line crosses the y-axis at the point 0, 1. The slope of 2 tells us that for every 1 unit we move to the right, the line goes up 2 units, so it's pretty steep. This means the equation for the line is y equals 2x plus 1. When graphing, you should start at 0, 1 and then go up 2 and right 1 to find more of the points on the line. Now it's your turn to graph linear equations. Pause the video to try it, then check your answer. Graph the linear equation y equals negative x plus 2. To start this problem, we have to understand that the y-intercept is 2, while the slope is negative 1. Start by plotting the y-intercept at 0, 2. Then, since the slope is negative 1, go down 1 and right 1 to plot the next point. After that, connect the points to draw the line, and you'll have graphed the equation y equals negative x plus 2. Let's connect what we learned about linear equations to physics. Imagine you're looking at a distance-time graph for an object moving at a constant speed. The equation for this line looks like d equals vt plus initial d, where v is the speed and initial d is the starting position. For example, if the equation is d equals 3t plus 2, this tells us the object is moving at a constant speed of 3 meters per second, which is the slope, and it started at a distance of 2 meters from the origin, which is the y-intercept. So at time t equals 0, the object is already 2 meters away, and for every second that passes, it moves 3 more meters. These types of linear equations are used in physics to describe motion and position over time, showing how the math we learned connects directly to the real world. Understanding this helps you read graphs and predict how far something will travel after a certain amount of time. It also forms the basis for solving more complex physics problems involving motion and speed. Now, let's practice solving these linear equations by plugging in x. If a gym charges a $20 sign-up fee plus $5 per class, what is the cost for 8 classes? Pause the video to try it, then check your answer. First, we need to write an equation that models this situation. Since each class costs $5 and there's also a fixed sign-up fee of $20, we can write the equation as y equals 5x plus 20. Here, x represents the number of classes and y is the total cost. Next, we plug in 8 for x because we want to find the cost for 8 classes. So the equation becomes y equals 5 times 8 plus 20. We can simplify this further by calculating 5 times 8, which is 40. So now we have y equals 40 plus 20. Finally, we add 40 and 20 to get 60. So the total cost for 8 classes at the gym is $60. This includes the sign-up fee plus the cost for all 8 classes. Our next practice problem will focus on the relationship between two linear equations. If line A is y equals 3x plus 1 and line B is y equals 3x minus 2, how are the lines related? Both lines have the same slope of 3, which is our first step to analyze. This means they rise at the same rate and have the same steepness on the graph. Our second step is to look at their y-intercepts, which are different. Line A crosses the y-axis at 1, while line B crosses at -2. This difference means the lines are shifted vertically relative to each other. Our third and final step is understanding that having the same slope means that the lines are parallel. Because they are parallel and have different y-intercepts, the lines will never intersect. No matter how far they extend, they will always remain the same distance apart on the graph. You can test this by plugging in any x value into both linear equations, and because the lines are parallel, their y values will never be the same. Finally, remember, linear equations follow the form y equals mx plus b, where m is the slope, calculated by rise over run, and b is the y-intercept. We learned to graph by plotting the y-intercept using the slope, and saw real-world examples like gym fees and physics. Keep practicing to get better at using these equations, and thank you for watching.